Namaskar my dear friends. So we have seen LM2596 simple switcher step down converter design and details. Okay, so complete design and details we have seen in our last session. Now what we will do is we will implement 5 applications using this LM2596. One of them will be 3.3 volt 2 ampere, 5 volt 2 ampere, 12 volt 1 ampere. So all these three will be using fixed regulators. Okay, and two more application that we will see, which is 7.5 volt 2 ampere and 17 volt 2 ampere. So these are used in like printer applications and all in medical devices, like 7.5 volt is utilized or 17 volt is used in motor driver applications and all in medical devices. So this is the reason these 5 application we'll try to understand. Okay, so as we have already seen that this particular buck converter is capable of taking the input from 4.5 volt to 40 volt. Okay, and is capable of giving current up to 3 amperes. Okay, so you can utilize make changes to make it 3 ampere as well, but my requirement was the client requirement was up to 2 ampere only, so that's the reason it has been designed. Okay, so you had already seen the fixed output series buck regulators. What was the thing that we have V input, we need V output here. So we need to select what is my input capacitor, what is my output capacitor, and what is the value of inductor. Okay, and we need to find out one of the catch diode as well. So only these 4 values are required to select and our design will be complete. So this is all about the fixed type. Coming back to the adjustable type, so what we have to do, you have V input, you have your V output that is required with your current rating. Okay, I out. The 4 values that we have to select is C input and then C output and the regulator, inductor and the catch diode, right? In addition to that, we have to design 2 resistor as well. Like this is my resistor feedback network R1 and R2. So what you have to do is, based on the output voltage, you have to design these 2 values to get your regulated output voltage. Okay, and if your output voltage is more than 10 volt, then there will be a need of feed forward capacitor as well across this R2. So that also will be like designed. Got it? So using this formula you can find out your R1 and R2 values, where V reference is 1.23 volt and R1 try to take 1 kilo ohm starting point, and using that you can design. Okay, good. So let us do the first design. The first design is we have a 3.3 volt 2 ampere output. So what I have done is, we have our V input and this is our input capacitor, which is 470 microfarad. This is our output capacitor, which is 470 microfarad. Again, there is no change in that. We have utilized one catch diode, which is of 40 volt 5 ampere rating from Nexperia. Okay, and we have selected the inductor based on the graph that I had shown in the previous video. So this is 33 microhenry that will be there. Okay, so before doing this, what you have to keep in mind is, you have to keep a design requirement. Okay, so let us say design requirement, you have to set out what is your voltage output. So let's say I want 3.3 volt. What is your input? So input is, let's say 12 volt. uh, if input changes, let's say it is 15 volt or it is 18 volt, then the basic change will be the inductor change, the L value change. Inductor will change. As you can see, we had the graph of I out, and this was my V input. Based on this, there were graphs to get the inductor values. Okay, so inductor selection will be different, and I out you have to fix based on your 2 ampere or 3 ampere or 1 ampere or whatever. And switching frequency you don't have to set in this particular LM2596, because it has fixed switching frequency, which is of close to around 150 kilohertz. Okay, so this much you keep in mind. Okay, like what is your input voltage, what is your output voltage, and what is your output current. So based on these three parameters you will be able to design your complete voltage regulators. Okay, so hope you have a good understanding of now. Like my input voltage is 12 volt, output voltage is 3.3 volt, 2 amperes, my output capacitor, then we have inductor selection, we have catch diode selection, and we have input capacitor selection. Okay, and I have not used here on off control, I have directly made it always on, and we have the tab is also grounded, and this particular IC is actually TO263 package. So this is having very good heat dissipation capability also. This one is the T20 TO263 package. Okay, so this is the one which I have used in my applications. Got it? Now coming back to the like design procedure, as I mentioned already, like you have to select the inductor, you have to select the output capacitor, then catch diode, then input capacitor, and if there will be a need of adjustable regulator, then you have to find out R1 R2 value based on the feedback network. Okay, and where the formula I just now showed you, this was the formula that we used to find out the R1 and R2 value. Okay, let us move to the second application. Second application is my input voltage is 12 volt and output voltage is 5 volt 2 ampere. V input is 12 volt, V output is 5 volt, and I out is 2 ampere. Okay, so based on these settings the input capacitor is chosen as 470 microfarad of 25 volt rating. Output capacitor also is chosen as 470 microfarad 25 volt rating. Then one of the catch diode, same catch diode I have used as I utilized in 3.3 volt regulator. Okay, and we had to just change the value of inductor, which is 47 microfarad based on this requirement. Okay, so this is all about a 5 volt regulator with 2 ampere outputs, and this is very sturdy device. This is prominently used in medical applications or home theaters or appliances and all. Coming back to 12 volt, so 12 volt, what I have done is I have an input of 15 volt, I have output requirement of 12 volt, and I output requirement of 1 ampere. Okay, so the change will be capacitor voltage rating. So voltage rating I have increased to now 63 volt. So this is my input capacitor, output capacitor also same will do, and we have this catch diode which is taken, and we have the inductor selection based on the graph that we use, right? So based on these three things, these four selections, we are complete with our design. So as you can see, I have given you the part number of each and every ICs of fixed version. Like this is 12 volt, so LM2596S-12/NOPB. Okay, similar to that for 5 volt version, it is LM2596S-5.0/NOPB, and for 3.3 volt version it will be LM2596S-3.3/NOPB. Okay, so this fixed volt version regulator is designed 3.3 volt, 5 volt and 12 volt. Now coming back to the adjustable version regulation. Okay, so I have designed one of the application which is my V input is 12 volt and V output is actually 7.5 volt, which is basically used in printers and all in medical devices, and I output is set to 2 ampere. Okay, so what I have done is we have the input capacitor selection, so that is done. So input capacitor is selected, which is of 470 microfarad 25 volt rating. Try to keep voltage rating at least twice. Okay, don't go for 1.5 times, twice or thrice also you will do. So even if you want 470 microfarad with 35 volt rating will be even better. Okay, coming back to the output capacitor, so output capacitor is also selected, right? Then catch diode, you have to select catch diode, let's say 5 ampere rating with 40 volt capacity. Okay, now based on the graph, we have selected the inductor value which is going to be 100 microhenry. Sorry, it is microhenry, this is typing mistake. Okay, so 100 microhenry. Okay. Now the main point is I have used this particular application to switch it on, switch it off based on the need. Okay, so let's say my switch enable. What is happening is there is a controller here. Okay, or if you want you can control somehow other as well, but we have the microcontroller here which is coming as IO, and this IO, once it goes high, what will happen? This will go like start working. Once it starts working, this on off control will go pull down, and this is how this particular regulator will start working. Okay, so this is the enable circuit that is utilized to make this switch on switch off. Okay, now there was a calculation to calculate your V output. So V output was what? V reference into 1 plus R2 by R1. So based on this formula that just now I showed you, you can see here, let me just show you. V out is equal to V reference into 1 plus R2 by R1, and here V reference was 1.23, and based on that R2 value we can calculate based on this particular formula, which is R1 into V out by V ref minus 1. Okay, so let me take this here. Good. Okay, so as you can see, once we put R2 value as don't consider this R1 R2 directly here. I should have done this. Let's say this is R10 and R11. Okay, okay, so this R10 value and R11 value, what I have done is, let's say R11 is considered as 1 kilo ohm. Okay, then R2 that is here actually will be calculated based on this particular formula, and it will come as 5.1k. Okay, so 5.1k and 1k combination is going to give you the output voltage to 7.5 volt, and one feed forward capacitor is also put. Even if you do not put, since the voltage output is less than 10 volt, so it is not needed, but this is good practice to keep it. Okay, if there is a need, then you can always put it. So 3.3 nanofarad is put here. This particular jumper short is put just because of, suppose you do not have a controller output right now available. Okay, or you do not have the program to set it on or off, then what I have done is you can switch, like sort it out. So you can sort this jumper so that it will be pulled low, and this is how you will get your output. So this is the reason I have put this particular MOSFET switching as well as this jumper sort to get your output to 7.5 volt 2 ampere output. So this was all about adjustable version regulator. Okay, so adjustable version regulator of LM2596 we have designed from 12 volt to 7.5 volt 2 ampere ratings with all these parameters. Coming back to one more application which is going to be 17 volt. So my V input is actually 24 volt and V output is 17 volt, which is used in our motor application with current rating of 2 ampere. Okay, so what I have done is I have chosen my input capacitor, my C in is done, then output capacitor C out is done, then we have the catch diode which is chosen to be 40 volt with 5 ampere capacity. Okay, then based on this output voltage and output current rating, we have to choose the inductor value in the graph, right? And my R1 R2 value, which is here R5 and R6. Okay, so that is used. 1.02k was the starting point of R1 value, then based on that R2 value was calculated to 13k. These are standard values that has been utilized to give you output of 17 volt. Okay, and the feed forward capacitor is used to be 2.2 nanofarad based on the calculation. And same switching circuit I have used, okay, as I showed you in 7.5 volt application. So what I have done is this particular MOSFET will switch it on once you make the IO controller IO to high. This is my high, this is my low. So once it goes high, this will start working and on off pin will be pulled down. Okay, Coming back to this particular sort, so if you do not have the controller output or something like that, you can still control your switching regulator to give you the output by sorting this 2 pin. Okay, so once you put a sort jumper, then you will be getting your output to 17 volt 2 ampere ratings. Okay, good. If you wish to have, you can utilize these two capacitors. One is taken from Worth Electronics and another one is Kemet. So both are 470 microfarad of 20% tolerance with 63 volt ratings. So 63 volt rating with 470 microfarad. These two capacitors are there. Any one of these two parts you can utilize for this application. Good. So you have all these three applications, all these 5 applications. 3 were from fixed version and 2 were from adjustable version. If you do need some other voltage regulation, let us say 15 volt 3 ampere or any other voltage, let's say even 20 volt 3 ampere or 2 amperes, so any other voltage output or something like that, if you want to design and you are struggling with designing the feedback circuit, or maybe what should be my C input, what should be my C output, or what should be my L inductor value, or what should be my diode part number or something like that. So these 5 things you have to try to design it, or you can put down your queries in the comment box to design your particular application related voltage output. Okay, so alright guys, thank you for understanding all these regulators and all the applications that is applicable using these 5 regulators that we showed in this particular session, and you try to expand your or extend your knowledge based on this particular design to other as well. Other ICs also will be having almost same application. There are no much changes in design process. So this particular design process you have to always keep in mind. It's like what is your voltage output, what is your voltage input, what is your I output requirement, and then design process was very simple, which was inductor selection, then output capacitor selection and input capacitor selection, then catch diode parameters and voltage setting based on the adjustable versions. Okay, so these 5 steps is going to make your life much more simpler to design any of the regulator that you wish to design. Okay, thank you so much.